We're going to talk now about variable naming, which is very important if you're going to be doing regression analyses. And when you're naming your variable, there's two options. First of all, your first option is to just simply use the variable named as it is. If it's coming right out of a database, it's usually going to be named based on the form that it represents that it's coming from, as well as the question number on that form. And this you can do if you're simply not going to use the variable in a lot of regression analyses. In other words, if this is just a pass-through variable, that you're using it to generate a composite variable, which is then going to be used more later on. The other option is that you want to actually rename the variable, and this is going to happen. If you're going to do that, you're going to want to give it an intuitive name, not a name just based on the form, which is usually somewhat random. And you're going to want to do this if you're going to use it in regression models, or especially if there's going to be multiple people using it. In other words, they're all going to want to understand what these variables mean. Let's give you an example of when you might just simply use a pass-through variable. Let's look at this mini mental state exam score. This is a score to measure cognitive ability. And if we import the data from the raw database data, you see the form is called MMSE, and there's lots of questions which have numbers which range from 1 all the way up to about 19. But of course we don't really necessarily need to use all these, and you can see that if you actually run the do file which analyzes this data, once you run it, then at the end of the day it actually boils down to a single score, which I just call MMSE. So there's no reason that you need to actually have descriptive variable names for all of those 19 different questions and even more sub-questions. So, however, you do want to have a nice intuitive name for that composite score, and MMSE is just fine over there. So let's give us some principles of variable naming. First principle, you'll understand why it's important as part of other lectures, but just take it for granted right now, that all the letters in your variable name need to be lowercase. And you'll see why that is as part of other lectures that we're going to give you. And the second is you need to know when you need to separate parts of the variable name. And when you do separate them, you want to separate them by an underscore. At least that's what I like to use. And so there's three options. So option A regarding separation is, of course, to not separate variable aspects, various aspects of the variable name. So for example, if we're looking at visual acuity in the right eye and left eye, these may be named VAOD, OD means right eye, and VAOS, OS means left eye. Since it's so short, even though there is only a one-letter difference, it stands out pretty easily, and so there's no need to do that. Let's say that we now have a more complicated name, and we're looking at best corrected visual acuity in the right eye at baseline. And we're also going to look at best corrected visual acuity in the left eye at baseline. Well, this is a little bit complicated. Are you really going to be able to see the difference in this D and the S right over here? So I would suggest over here that we use a single underscore to really highlight that difference better. So you can go at BCVAOD and BCVAOS underscore baseline. And now you can see this difference much more clearly. It stands out much better. Let's say we have a really complicated example where we're looking at the integrated visual field, 5 decibels of worsening, and we're looking at it using two methods of visual field integration called the binocular summation and the best sensitivity by location. And then each one of these we're averaging in two different ways. We're taking the decibel average, and then we're taking the exponentiated average. Well, now this is a very complicated thing, and say we actually want to look at all of these 4 things as part of our data set. We want to have a very detailed variable which explains all that. So for example, this variable right over here, you might call IVF 5 worse, and then binocular summation, and then decibel average. So you have 3 parts, and this one is going to be IVF 5 worse, best location, exponential average. You say, well, these are really long variable names. Do you need something so descriptive? I would argue you do, and you don't actually have to write all these things out. When you're in STATA, if you simply double-click on the variable name, it'll actually bring this up, and you can put it into the model that way. So you're not going to be typing this out very often. So let's talk about some special considerations now. Let's say that we're actually looking at a dichotomous variable. This means that it has 2 outcomes. I like to assign a value of 1 if the outcome is true, and 0 if the outcome is false. And so I like to actually have the variable actually tell you or guide you as to what the true value is and what the false value is. What do I mean for that? So, for example, you could have a variable which says depression. What exactly does that mean? I would say instead, don't call it depression, but call it depressed. That means if the patient is depressed, that means the value is going to be 1. If they're not depressed, it's going to be 0. What's another example? So you can, if you had different categories of vision, you can say VA cat. I would instead say poor VA. So that tells you that if it's 1, that means that they have poor vision. You can do something called education level, or you can say what that level is defined by. So for example, did they finish college? And that's going to be 1. Let's give you one other example real quickly. So, and this is for now continuous variables. So when you have a continuous variable, you want the variable name to tell you a couple different things. First of all, you want to tell you the interval of change that it's representing. And so then the default is going to be 1 unit of whatever that variable is. And second of all, you want to know the direction of change. So the default for me is always the positive direction. So let's give us some examples here to illustrate this a little bit better. So let's say we have a variable which indicates the number of comorbidities. I think this can be written just as it is, because one unit higher value means 1 more comorbidity, and a positive direction means that you have 1 extra, 1 higher number of comorbidities. Let's say on the other hand we have something like education. A year of education may not be that meaningful. For example, if you finish college, that's going to be 4 years. So we may want to have an interval of 4, meaning that education 4 means that if you have a 1 unit higher value of education 4, that actually means 4 more years of education. So it tells you the interval, and it tells you the direction means more. For example, if we wanted to look at mini mental state exam score, we may not want to look at a 1 point because the values go from 0 to 30. Maybe you actually want to look at a 5-point increase as being meaningful, so we call MMSE 5. Or on the other hand, you may want to actually have the interval indicate that they actually have worse cognition, in which case I would probably put in an underscore and call it 5 worse. Let's say we actually wanted to look at an interval that's less than 1. So for example, logMAR visual acuity goes from 0 to 1. So you want to know a 0.1 change. Well, you can't put decimal points into STATA, but what you could do is instead of using just logMAR, which would indicate, if you just put in that means that you're looking at a 1 unit change. You might say 0.1, indicating that you're looking at a 0.1 unit change. Or you can write down logMAR 10x. It's a little bit confusing why, but basically you actually have to multiply the baseline logMAR by 10. And when you multiply it by 10, each 1 unit change actually represents a 0.1 unit change in the actual logMAR value. There's one final example which I'd like to bring up just because it does come up occasionally. Sometimes you're looking at longitudinal studies. And then you're going to have a number which indicates which year of the study you're looking at. So for example, you might have year 1, let's say it's a 3-year study, and you may want to look at the mini-mental score at year 0 and at year 3, and you want to look at an interval of change of 5. Well, if you put 5, does that mean it's year 5, or does it mean that it's 5 better? Well, I would probably write down 0. I usually like to put down the year right next to the variable and link those two together. And then I would put an underscore, and now I would say 5 better to indicate that this means 5 units better. And in year 3, this variable will become MMSE 3, 5 better. Likewise, logmar year 0 would be described as such. And at year 3 would be logmar 3, 10x. That's all for now. Thank you.